Welcome to the corner and interest point detection in computer vision. My name is Shegun, your host. Let's go. Corners are like special points in an image that stand out, like corners of a building or let me say an intersection of two edges. Algorithm like Harris corner detector and Shi-Tomasi corner point detection are used to actually find a very reliable point that does not change much under rotation or scaling. You understand this point now? It is a very important point that does not change under rotation or changes. If you actually rotate this particular point will still remain constant. You understand? And computer vision, as we all know that it follows the its procedure of actually like doing something and being able to like seeing an image and being able to like tell stories about it is a significant involvement in the world of technology. And today we'll try to like explore how this always detector and Citomasi detector actually works. I'll be starting with Aris corner detector, where I'll be using a particular location in Lagos, a popular location called Computer Village. We are looking at the street of Computer Village. We are trying to implement Aris edge detector in an overlay. So we've gotten an image online. We'll try to see how this works in real life. Let's go straight into our code lab. So the very first thing we have to do is import our image in grayscale format. So we bring in our image, let's say computer village, CVA. Okay, let's say computer, let's use village is equals to CVT color, then bring in our image. Our image is CV2 dot imread, then we bring in a computer village image from our imported files. So we'll be able to bring in our image is CV2, then we cv2 dot, we want to make it a grayscale, so we have color underscore bgr to rgb. If I'm right, something like, yeah, correct, we're importing it correctly. So now the first thing we'll first do is we apply our arrays. But before we apply our arrays, we need to convert this particular grayscale into floating point. So we're converting our computer village into a floating point that we can manipulate it for our arrays detection. So array computer village is equal to computer village. There's cv np.float is converting to a floating point 32 grayscale sharp. So we have it converted into a grayscale and in floating points. So next we want to apply our arrays corner detection. You understand our image. So let's say detect. So cv2 dot corner harvest. Then we have our computer village image. We have a block size, which are one of the parameters we can actually import here. A block size will actually be applying 17. Let's apply 17. Now we can have a uniform result as what we had earlier in our on our screen. Then our key size, which is the next value we have, let's make it 21. Then our key, main key itself, let's make it 0.01. So what is happening here? So now from what we have here now, computer village is actually our input image in grayscale format. 17 is the size of the neighborhood considered for corner, like the size of the neighborhood we're actually trying to consider as a corner in an image for detection. The bigger the block, the smoother we have, the smaller the bulb, the block, the more sensitive we have. So the next we're having is our key size. The key size is size our subject kernel is using to compute image derivative. Why k is like the sensitivity factor for detecting corners. Smaller k means more corner detected. The more our k is small, the more corners we'll be detecting. So now we want to make the detected corners more visible. All we do is we make our DST be more visible by using a dilate functions. So we DST dot none. So the purpose is to actually make our corners more visible. We expand the bracket and the bright spots in the DST matrix so that each corners cover slightly bigger areas. It is more like you using a pen highlighter to thicken a mark on a map than making the corners become easier to see. So you're using an highlighter to tick a particular areas in a map. Next, we create an overlay of corner in red. What we'll do next is we'll draw a dictate. We run into an error. Let's see what is happening. Oh, sorry, we cannot use it directly. We'll call it from CV2. I think now we shouldn't be having any problem. We are still having the same problem. Let's see. Let's see if 32 corner point degree value. So we'll come back here. This is where the mistake comes from. So that's one of those things about computer vision. You have to be very quite careful of not doing the wrong thing. It should work now. Yeah. So now we have the image working as we're able to like apply Harris corner detector to it effectively. Now we are creating an overlay of red. So overlay we are creating is overlay. We are creating overlay to the image. The image we are actually using is the version in RGB format. To do this, to make it more easier, let's copy this image RGB, right? Let's use an RGB format of that particular image. Then we convert our image back to RGB. That's the best way to make it easier for us to understand. Then RGB, right? So we copy this, we paste it here. Now we have the overlay of an image in RGB format. Next, we would create an overlay of DST. We are using the copy version. Then DST greater than 0.01, 0.01, you multiply it by DST dot max, then is equals to, then we give it to the color we're giving it is red. So should we give it red? Let's give it something. Let's give it red. I think give it red in our example. So we've been able to assign red to it as a color. Next we want to display our images. Let's see. Okay, we don't have image. We don't have volume, thank God. So the major thing we did here was we were able to like bring back our image to life, and the Harris corner, or let me say edge detector we carried out here. We are pasting it on our image. You understand? So let's see what our output looks like in the first place to be able to like explain more. So plt.figure, then we have a fixed size to be 12 by 6. So we have our subplot 1 comma, because we're declaring two image, right? So plt dot that's why we're actually using that. So plt dot show, then we have our original image. Original image is on computer village. Then plt dot title original, plt dot axis. We want to work our axis. So we're trying the second one. Number 2. This one is the Harris corner overlay. The one we apply overlay to. Harris corner overlay. We're bringing our overlay. This is what we have as image here. But we are not getting our original image. Let's see what's happening. Okay, let's bring is the one for RGB we want to use as our real image. So we use RGB of this because we know that one has actually been converted to a GraphQL format. Here we have our right result here, and that's how our risk corner detector works. If you look at it very well, what is happening here is it's trying to actually detect some corners. Even if you flick this image to in another dimension, you will still be getting those particular corners. They will still be existing. Obviously, it could be upside down, but still you still be having them available and present in this particular image. Thank you for sticking with us to this side. Next, we're having corner and interest point detector based on Tomasi.